Hello class. Today we are looking at section 9.1, radical expressions. Turn to page 647 and let's look at a little vocabulary. On page 648, it talks about the square root of A. On page 649, it talks about the definition of square root of x squared. It says if x can be any real number, then the square root of x squared equals the absolute value of x. On page 650, it talks about the cube root of a. On page 651, it talks about the definition of the nth root of a to the nth power. It says if n is an odd natural number greater than 1, those are my positive integers, then the nth root of a to the nth power is a. If n is an even natural number, then the nth root of a to the nth power equals the absolute value of a. And then on page 652, it talks about the nth root of x. So if you notice, I did stress certain vocabulary terms, and the others you need to make sure you go back and read them in your textbook. Now turn to page 657 and let's look at number 39. Page 657, number 39. It says find each square root if possible. So these are very easy. Now we talk about square roots. When we talk about square roots, we know that I need to find one number that I can multiply twice to get that answer. On 39, I have the opposite of the square root of 64. So right here, I want to think about, well, what number can I multiply twice to get 64? And I know that number would be 8. So my answer is 8, and then we have to bring down that negative sign. So my answer is negative 8. On number 43, I have the absolute value of negative 4. So I have to think about what number can I multiply twice to get negative 4. And when I think about it, I know 2 times 2 is positive 4. And I know negative 2 times negative 2 is also positive 4. But I can't think of two numbers that's going to be identical that's going to equal negative 4. So my answer here is not real. Let's go to the next section. It says find each square root. Assume that all variables are unrestricted and use absolute value symbols when necessary. So that's going back to that vocabulary that we read before we started our lesson. Look at number 47. So 47, I have the square root of 25x squared. The square root of 25, 5 times 5 will give me 25. So the square root of 25 is 5. And then the square root of x squared, two letters, the same two letters that can multiply give me x squared will be x. But I'm going to do the absolute value of x. And that goes back to our rule that we just read, which is on page 651, the definition of the nth root of a to the nth power. So make sure you read that definition. And that explains how we do our absolute value. Most textbooks, they don't usually do the absolute value. They just say 5x. But this book does stress the absolute value of x. So we want to stress it as well. Let's look at number 53. And we know the definition of absolute value means that whatever we put in for x is going to come out positive. Absolute value is the distance of a number to 0. So we say if we put in 2, we know that the absolute value of 2 can have two solutions. It can be positive 2 and negative 2 because both of those numbers are 2 units from 0. Okay, 53, I have a squared plus 6a plus 9. If you notice, I'm looking at a trinomial. We can factor out trinomial. This is a perfect trinomial because a times a is a squared. And then 3 times 3 is 9. Positive 3 plus 3 is positive 6 in the middle. If I want to rewrite this one more time, I have a plus 3 squared. In your index is understood to be 2. So in this space right here, this is called your index and it's understood to be 2. So what happens to my 2 in my index and my exponent 2? They cancel each other out. So my answer is the absolute value of a plus 3. Number 57, it says simplify each cube root. So before you look at 57, go back and read the definition of the cube root. So that's important to read those definitions. On the cube root, I have the cube root of negative 27. Now, if you take your calculator and you plug in the absolute value of, if you plug in the square root, let's try this out. If I plug in the square root, so I'm going to say second x squared, and then if I say negative 4, if you notice it gave me an error because we can't take the square root of a number, of a negative number. If we take square root of a negative number, it's not real. So let's try, what would happen if I do the cube root? So I'm going to go to my math button, and I do see that cube root. And I want to do the cube root of negative 27. And wow, they gave me an answer. The cube root of negative 27 is negative 3. And the reason that works because 3 negatives make a negative. If I break down negative 27, well, I know 3 times 3 is 9. And then I also know 9 times 3 give me 27. But I want negative 27. So negative times a negative makes a positive 9. And then positive 9 times another negative 3 makes negative 27. And the index tells me how many parts has to be the same. So I need 3 to be the same to come out of that root. So my answer is negative 3. The index tells me how many parts under the radical must be the same. What's underneath the radical is called the radicand. So if I look at my radicands, I see 3 negative 3's. So because I see a set, it comes out of the root. And it's just negative 3 is my answer. And also you saw in the calculator, when I typed in the cube root of negative 27, it gave me negative 3. Look at number 63. I have the cube root of 125 y to the third power. So on this one, I want to find 3 of the same to pull it out of the cube root. If I break down 125, I know that 5 times 5 is 25, and 25 times 5 is 125. And then I have 1, 2, 3 y's because my exponent of 3 tells me I have 3 y's. So right here, I need 3 to make a set. I see 1 set of 5, so I write it down 1 time. And I also see 1 set of y's, so I write it down. So that is very important. So you do cube roots, it doesn't matter if what's underneath the root is positive or negative. But when you do a square root, or a fourth root, or a sixth root, it does matter because you cannot have a even amount of negatives. An even amount of negatives will make a positive answer, not a negative solution. An odd amount of negative signs will make a negative answer. That's why when you do cube root, fifth root, seventh root, it's okay if you have a negative under the root. Look at number 65. 65, I have the cube root of negative 1,000, p to the third, q to the third. I need to see how can I break down that negative 1,000. Okay, so right here, and when you do your cube root, make sure you write the 3, because if you do not write the 3, it's understood to be a square root. So it's so important that you keep writing down that 3. If I break this down, I know 10 times 10 is 100. And 100 times 10 is 1,000. I want negative 1,000. So I'm going to do negative times negative is positive times negative is a negative 1,000. And right here, I'm going to just keep it as p to the third and q to the third, because I can see that the 3's will cancel out. Okay? So I see one set. I need 3 to make a set. I see one set of negative 10. P to the third, that's 3 p's. So I have one set of p, and I have 3 q's, so that's one set of q. And that is my answer for 65. Number 71 says simplify each radical if possible. So let's look at 71. So 71, I have the 6th root of 64. Now right here, you can again do your mental math, or let's just practice doing a factor tree. Well, I know 8 times 8 is 64. I need 6 of the same. I need 6 to make a set this time. Break down your 8. I know 2 times 4 is 8. 4 times 2 is 8, however you want to write it. And then 2 times 2 is 4. So what do you notice? I see 1, 2, 3, 4, 5, 6. I see 6 2's. Check your math to make sure you marked everything correctly. So I broke down 71 into its prime factors. But if I go back and do my math and check it, 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2 is 32. And 32 times 2 give me back to 64. So I know I marked all the numbers I need to use. So you break down your prime numbers. Once you get to your primes, you're done. I see the 6th root of 2. I see 6 2's. So the 6th root of 2 to the 6. If you notice, the 6's go away. I'm left with 2. So the 6th root of 64 is 2. And again, I want to stress that 2 to the 6 is the same as saying 64. Very, very important. Number 75. I have the 4th root of negative 256. Now right here, I need 4 of the same numbers in my radicants to make a set. Okay, underneath my root. All right, but again, we know that if we do an even amount of negative numbers, it's going to come out positive. So I cannot find the same number multiplied 4 times to get negative 256. So because this is an even number and it's a negative under the root, it's not real. And when you get to math 112, you will talk about the word imaginary. But for this class, we're just going to say not real. Okay, the next part says simplify each radical. Assume that all variables are unrestricted. and use absolute value symbols where necessary. Okay, look at number 83. I have the fourth root of 1 over 16 x to the fourth power. So I need 4 of the same in order to bring it out of that fourth root. So I have the fourth root. I know that 1 times 1 times 1 times 1 is still 1. So I can rewrite this and say 1 to the fourth, because 1 times 1 times 1 times 1 is still 1. Now let's think about 16. What number can I multiply 4 times to get 16? And that number would be 2. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. So 2 to the fourth power will give me 16. And then I do have that x to the fourth. And I want to make sure that x comes out to be a positive answer every time. So we're going to put those absolute value bars around that. We want that to be positive every time, because we're dealing with a even index and we have a negative solution. It can be, it's not real. We want everything to come out real, to be a real number. Now going from there, I have the fourth root of 1 to the 4 is 1. The fourth root of 2 to the fourth is 2. And the fourth root of x to the fourth is the absolute value of x. And this is how the book writes that answer. So again, I'm just canceling out. I'm basically saying 4 going to 4 once. I'm left with that 1 there. 4 going to 4 once. I'm left with that 2. And then 4 going to this 4 once. I'm left with that x. And that's all I'm doing. I'm just canceling out. So it's very important that you look at that. You're just basically simplifying the problem. Number 85. So 85, we have the fourth root of x to the 12th power. Okay, right here, very simple. We know 4 goes into 4 1 time, and 4 going to 12 3 times. So the fourth root of x to the 12th is x to the third. Now, if you don't like that, there's so many ways you can work these types of problems out. I know that I need 4 of the same to make a set. I can break down my radicand and I can say x to the fourth times x to the fourth times x to the fourth. Now you have to remember what we learned about properties of exponents. Properties of exponents say that when I multiply, I add the exponents. So 4 plus 4 is 8, plus another 4 is back to 12. So I see 1, 2, 3 sets of x to the 4s. Okay, so I see 3 of those. That's why my answer will be x to the third. So I see 1 set here. I see a second set there. I see a third step here, a third set there. And then you count those x's, those exponents, which is x to the third. So you can decide which way you like better. You can simplify 4 going to 12 3 times, or you can break it down, pull out your sets, and then you simplify it from there. So whatever way you like, that's the way you try it. 89. We have the cube root of negative 27, a to the 6th power. I need 3 of the same. So we've already talked about negative 27. We know that I need 3 negative 3's. I'm going to say a to the third times a to the third, because it's 6 of these, so I just broke them up in half into 3's. That way I can pull out my sets. I see 1 set of negative 3's. I see 1 set of a to the third. I see another set of a to the third. So when I finish my answer is -3, 1, 2, a to the second power. So very, very easy. So make sure you look at those examples for this section. Very easy sections. Just remember that when you're talking about the square root, fourth root, sixth roots, you want to remember those absolute value bars around it. We know absolute value means it's the distance from a number to 0. Very important. Cube root, just know that a cube root, the radicand can either be a positive or a negative number, because I can multiply 3 positives and it'll be fine, or I can multiply 3 negatives and it'll be fine. But what I cannot do when I'm doing square roots, I cannot take the square root of a negative number, because it will be not real. Okay, so that is it for section 9.1. Continue studying and working on your work. And any questions or concerns, please let me know.